Hello, 7th graders, and welcome to lesson 9.4, which is on measures of variation. So for the most part, in the things we've been doing so far this unit have been a majority of review. We've added a few things that are newer, talking about outliers, talking about the best way to measure things, what's the best measure. In this one, we are definitely going to be talking about things that are different, and I know that you have not seen this yet before. So what we're going to do is I'm going to read off our icons and I'll kind of explain a little bit more what we're doing. So I can find the range of data sets. I can find the interquartile range of data sets, and I can check for outliers in data sets. So a lot of times when you're talking about mean, median, mode, you also add in range. So a lot of times they'll say, hey, the mean, median, mode, and the range. So for the most part, the basic range should be something that you also had learned at some point in math over the years. This interquartile range, though, is going to be new, okay? So we're going to talk about how we find quartiles and how do we find the inner quartile range. So please make sure that you're listening very carefully. Let me know if you've got questions because this is a little tricky, but follow along as best as you can. Feel free to go back and review these lessons if you need to. All right, skipping our warm up. So we're going to go ahead into then the first part, which is how can you describe the spread of data? So we've already been using that. How can we describe the spread of data? Well, we've used mean, we've used mode, we've used median, okay? We've talked about statistical questions. Are they statistical questions? Are they not? We could put things in a table like frequency tables, right? So what are some other ways that we can represent or even describe our spread of data? Well, we can talk about range and our interquartile range. So typically your regular range is going from the smallest number to the highest number. So in that last video, when we were talking about those shoes, and you had this shoe that was $122 and you had this shoe that was $20, well, I want to find the difference between the two. So 122 minus 20 is then $102. So that was the difference between the prices. That's your range, okay? So it's spanning from 20 to 122. That's a range of 102 different digits in between. Your quartile range or your inner quartile range, or sometimes they label it as IQR, revolves around these quartiles. So here is what quartiles are, and you need to understand how to find your quartile first before then you can do your inner quartile range. So the quartile of a data set, divide the data into 4 equal parts. Recall that the median, the second quartile, divided the set into 2 halves. So basically, I don't like this definition. Straight up confuses me. Typically, in your data set, you have 4 different quartiles, okay? They label each one with a big Q and then this little number below it. We are only really going to be concerned about your quartile 1 and quartile 3 right now, just to make things easier. If we need to, we'll talk about quartile 2 and quartile 4. But we're just going to think about the odd ones, quartile 1 and quartile 3. So what it is that you, like before, are going to set up your data from smallest to biggest. You are going to find your median. So in this case, the median is 29. So that means then from 29, there should be the same amount. If it was an odd number, there'd be the same amount of numbers above that median and the same amount of numbers below that median. Okay, so you're basically going to break it up into 2 halves. You're going to have a lower half, which is what they say here, and you have an upper half. Okay. The median then of that lower half is considered to be your quartile 1. So that first quartile. So then you go ahead and you look at the lower half and you go, okay, what's the median of the lower half? Well, it's 22. So that's my quartile 1 or my first quartile. Then you go to the upper half and you find your upper half. Okay, the median here is then your quartile 3. So what happens is that the median is actually your quartile 2. We don't need it right now, but just so you heads up, your your median is your quartile 2. So that's why we go from 1 to all the way to 3 here, because you go 1, 2, 3, and your fourth would come after this. All right, I'm going to move myself over here. So then your interquartile range is the difference between the third quartile and the first quartile. So basically then you're just going to find the difference. So you're going to subtract them. You're going to take this quartile 3 and subtract the quartile 1. The IQR represents the range of the middle half of the data and is another measure of center. So then it's showing you that kind of middle part of the data. So it's not looking at the really low numbers and it's not looking at the really high numbers. We're looking at kind of the middle. So when I take this 32, I subtract 22, I get then an answer of 10, and that's my IQR. Okay, this will be really important. Feel free to come back to this page and listen to this explanation if you need to, or look at it on your notes. Take it slow with this one because I know it'll be a bit of a challenge. All right, let's move me. So example 1, we're going to take a look at this and how do we solve this out. So the table shows the links of several Burmese pythons captured for study. So someone went out, they wanted to capture these pythons and they're going to study them. Find and interpret the range of their lengths. Okay, so basically I want to find that number, and interpret is basically explain. Explain, what does this mean? So as I can look at my table here, I've got all these different pythons and they've got different lengths. Okay, so I've got all these different numbers, and it looks to be that there is 10 different numbers, so it looks like they caught 10 different pythons. Sorry, this was just a repeat when I copied over from here. So first thing to do, figuring out your range, is I would start again by just, almost every time you're going to want to start by ordering your numbers from smallest to biggest. So to find the least and the greatest values, order the lengths from least to greatest. Or you can kind of look here as well and be like, okay, 5 looks to be the smallest and this 8.5 looks the biggest. All right. So they said the least is 5, the greatest is 18.5, just like I did. So then your range, so this is just your typical range. That's all they wanted. The normal range then is usually just taking the bigger number, subtract the smaller. So the range of the lengths is 18.5 minus 5, or this would be 13.5 feet. So interpreting this then means that the lengths vary by no more than 13.5 feet. So that means all of these snakes fit within the range here of about 13.5 feet difference between each other at the most. It could be smaller because, you know, like 10 to 8 is 2. So it's just in between that largest and that smallest value. And that's just range. Remember, if they're looking for the IQR, they're going to put IQR, they're going to put interquartile range. Let's keep going. So I want you to try this one on your own. Find the range and interpret it. So explain, what does this mean? So this time you've got people who ride a roller coaster. So pick the largest and the smallest one, find the difference, and then interpret the range. Okay, so pause the video, solve this out, and when you come back, I will have the answer. Make sure you're pausing the video. Pause it now. Now. All right, welcome back. So finding your range, you're just taking the largest and the smallest. So in this case, the largest age was 52 and your smallest age, or your youngest age, was 11. So finding that difference is 41. So interpreting it then, again, I didn't write this out, but interpreting would mean that there is a difference between, at most, 41 age between the people who rode the roller coaster. Okay, so that's the biggest difference between the largest and the smallest. But anyone could be within that range of 0 to 41 years of difference. Okay, that's what that range means. Let's keep going. Oh, didn't know this. Hold on. Don't know why the answer's here. Let's make sure all the other ones are good. Sad day. Oh, sad day. I messed up. All right. Next example. So example 2. Okay. So example 2, we've got, it says the dot plot shows the top speeds of 12 sports cars. Find and interpret then the interquartile range. This is where we're going to talk about our quartiles and our inner quartile range. So here's our dot plot, okay? So here's the 12 different cars. I can tell it's 12 cars because there should be 12 dots, okay? And it's showing then the speeds, the top speeds all those cars can do. So we need to find and interpret this interquartile range. So your first step on finding this is to start off by writing the list of numbers in order, okay? So in this case, I would have 120, so I don't know what happened there. So you'd write out 120, then 120, or 100, or 220, 230. You'd also have another 230. Then you'd have 240, another 240. You'd have 245, and you'd also have 250, and 250, and 250, and you'd have 260, and 260, and then 270. So here's how they already kind of showed this spread. So again, like I said, you need to start with this part. Don't just expect to write all this down and understand the steps of doing it. I just put it up here because I'm still waiting on getting a keypad or a writing pad here for my computer, and it's just a lot less work than me trying to write it out with a mouse here, okay? In the upcoming videos, I won't be doing that as often as copying and pasting. So, writing out your number. Then you need to find your median. So you typically find your median, okay? In this case, my median is right in between two numbers. So that's why I have to find my average of it. So I add the two numbers together and divide by 2. So this would be considered my quartile 2. Because it's not a specific median and it's just one number, I break it right here in between the two parts that would be the median. So right in between here. So this part also becomes then the lower half. This part becomes the upper half. From there, then, you find the median of the lower and the median of the upper. So remember your median, you're going through, you're crossing off. You're like, okay, there's a lower one, there's a higher one. Oh, it's going to be somewhere in between 230 and 240. Well, in between there, or if you can just think, what's right in the middle? Without even doing this, you can make it easier on yourself. What's right in the middle of 230 and 240? Well, it's 235. So that's going to be your quartile 1. Okay, your upper half then, you take the same thing. You go through, okay. Oh, and I realize this one's between 250 and 260. Well, what's right in between 250 and 260? It's 255. So that is my quartile 3. When you go back then and you find your interquartile range, you're going to take this number and subtract this number. All right, so then it says, so for the quartile range, 255 minus 235 equals then 20. So your IQR is just going to end up being 20. And what it means then is this means that the median middle half of the speed varies no more than by 20. So they were taking a look at between here and here, basically. That's what they did with this. This interquartile is just looking at the middle of this data. In between here, they're going, oh, it can't be any different than 20 miles per hour. But you have to be able to figure out what is this middle. Okay. So then at the bottom here, they use the quartile and interquartile range to check for outliers. Don't worry too much about this, but that's one way that you can kind of check for outliers as well. But we're not going to worry about it right now. Usually we can kind of tell where our outliers are. Okay. So take it one step at a time. I cannot be more diligent about this because it can get overwhelming if you just look at it and go, what do I have to do? So you're basically finding median 3 times, okay? Write it all out, find the original median, split it into 2 parts. If it's one median, just keep it in the middle. If it's 2 here, then you take it one with the lower, one with the upper, and then you find the median of the lower and the upper, and then you just find the difference of those 2 medians. All right. I'm going to catch you here in part 2, so keep watching along. We will continue on in part 2. Hopefully that this will make a little more sense. All right, catch you then.